Hi and welcome to this demonstration on performing agglomerative clustering or hierarchical clustering using pollution data for India. I am Raghavendra, an expert in AI, ML and data engineering. By the end of this video, you will be able to apply agglomerative clustering on a dataset, visualize the clusters through the dendrogram, measure the strength of the clusters using Celoid scores. So first, let's import the libraries. Let's change the working directory to the dataset folder. Read the dataset pollution India 2010.csv. All the NA values is to be treated as null. So whenever you see a null as a string, it has to be treated as NA values. Let's preview the dataset. So here you can see you have the pollution for every state, every city, and you have computed some of the pollution metrics, that is NO2, PM10 and SO2. Let's check if any of these columns have nulls. So you do have for NO2 and PM10. So since there are very minimal records, so I'm just going to drop them from my data set. So let's check the shape after dropping them. I have a good amount of observations, 175 observations here. Let's check the data types. So we have city as object, state as object, and the other features are numeric. So for every state, I'm going to compute the total or the sum of each of the pollution metrics, that is NO2, PM10 and SO2. Let's take a head of this aggregated data. And this is the aggregated data which I'll be using for clustering. Before proceeding further, let's scale the data by subtracting every value by its mean and divide by its standard deviation. So I'm not going to take this string column state. I shall use this later for labeling my dendrogram. I'm going to drop it and then scale the rest of the columns which I will be using for clustering. So here is the scaled data for the columns NO2, PM10 and SO2. So I have totally 29 rows and 3 columns using which I will be performing the clustering. Before performing the agglomerative clustering, we will have to get the dendrogram. For that, I am going to import the dendrogram and the linkage from scipy.cluster.hierarchy. I am going to convert the dataset into an NumPy array. I pass this array of scaled data and into this linkage method to obtain the dendrogram to compute the distances using the ward method. I am going to save that in an object called as Z, and here I am going to plot the dendrogram, and let's take a look at the dendrogram. So here is the dendrogram for all the observations, where every observation of my data is corresponding to one state and I have them labeled over here. So if you can observe, West Bengal, Dadra Nagar Haveli, Daman Diu all belong to one cluster. Then Punjab, Jharkhand are going to belong to another cluster and so on. So you have these clusters which have been formed. Now from this dendrogram, you can roughly take the number of clusters as 9. And let's now perform the agglomerative clustering by importing this agglomerative clustering method from sklearn.cluster. We are going to run it for 9 clusters. So let's get the cluster labels. So you get cluster labels for each of the 29 observations. Now let's get the Celoid scores for all of these 9 clusters. Even the Celoid score is of 0.54. That's not very bad. Let's see if we can run it for different other clusters. I'm going to run it for 9 to 14 clusters and see if we can get any better Celoid score. If you can observe here, the Celoid score for 11 clusters is the highest of 0.55, and I am going to get the final cluster labels for 11 clusters. So, here the first observation is having a cluster label as 4. The second observation has a cluster label as 1, and so on. So, with this we are able to cluster our data using agglomerative clustering. In this video, we have learned how to perform agglomerative clustering, visualize the dendrogram and obtain the Celoid score. Thank you for watching this video.